I wanted to show you this website. This website does the type of sampling simulations that we were doing in class last night. Last night in class we were doing simulations in which I would select a sample of people randomly from a population. I would calculate the mean of the sample, and then I would randomly select another sample from the population and calculate the mean of that sample, and I would just keep doing it over and over, and I would just keep recording all of my sample means in a graph, and all of those sample means would start to pile up and form a shape of sample means. So this will do the same thing. I want to explain what this is showing. So right here, we have a population of 18,000 people. This is person 1 in the population. That's person 2, that's person 3. And it goes all the way down to person 18,000. This is showing the number of hours of sleep that each person is getting per night. So this person is getting 6.5 hours. Person 2 is getting 6 hours. Person 3 is also getting 6 hours. So it's showing the sleep times of all 18,000 people in the population. And if I added all 18,000 sleep times and divided the total by 18,000, I would get the population mean. In other words, I would get the mean of all population members. And we can see right here that the population mean comes out to 8.001, which is basically 8. And so we can see the population mean of 8 right there. And it makes sense that the population mean is at the center of the population. And down here we have some people who were below average, more sleep deprived. Up here we have some people who were above average and getting more sleep. Because there's a few people here who were only getting 4 hours, and a few people who were only getting 12 hours. But most people in the population are somewhere between maybe 6 hours and 10 hours of sleep. They're all in here. So the population roughly follows a normal curve, or a bell shape. If I click on Show Sampling Options right there, it lets me draw samples from this population. So let's say I want a sample of 3 people. I click on Draw Samples, and it randomly selects 3 people from the population and records their 3 sleep times. So this is the data that I've recorded from my sample of 3 people. If I added these 3 numbers and divided the total by 3, I would get the mean of my sample. In other words, I would get the average of my sample, and you can see that this sample mean comes out to 8.9. So if you added these 3 numbers and divided the total by 3, the sample mean would come out to 8.9. So over here, you can see the 3 people inside of the population. I don't know why it's only showing two dots. It should be showing 3. It's kind of strange. But here it shows the 3 people inside of the sample, and over here it shows the sample mean. This is the first sample mean that we've calculated because these 3 people had a sample mean of 8.9, and that right here is the sample mean. If I click on Draw Samples again, it gives me a new group of 3 people. It randomly selects a different group of 3 people, and it calculates the mean of this sample. If you added these 3 numbers and divided the total by 3, the sample mean would come out to 6.667. So our new sample of 3 people has this sample mean, and it plotted their sample mean right there. So this is the mean of sample 1, that's the mean of sample 2, and it always highlights the newest sample mean in blue. So over here, what we see is the 3 people inside of the sample. Over here we see the 3 people in the sample above a number line with the sample mean below it. And over here we see the sample mean as a building block. And if we draw a new sample of 3 people, this changes because it's now showing the 3 people in the new sample, which is sample 3. it shows the 3 selected people, and it puts the new sample mean right there. So these 3 things, this right here, this right here, and this right here, they're all showing the most recent sample. So these are we're now on sample 3. So these are the 3 people in our 3rd sample. Here they are again, and here they are again. And when you draw a new sample, it updates. This is now sample 4. So here we see the 3 people in sample 4. We see their sleep times. We see them right there, and we see that they have a sample mean of 8. So here we have the mean of sample 1, the mean of sample 2, the mean of sample 3, and the mean of sample 4. And if we click on a block right there, it'll show us the 3 people that were inside of that sample. If we click here, it shows the 3 people who were inside of that sample. So we can go back and revisit our old samples and see what 3 people were inside of each sample. So this was the mean of these 3 people. That was the mean of these 3 people. This is the mean of those 3, and that's the mean of these 3 people. Now if I keep drawing more and more samples over again, the sample means will start to form a bell-shaped curve. Because if the population follows a normal curve or a bell shape, then the means of the samples over here also form a bell shape or a normal curve. So if the population is normal, then the means of the selected samples over here are also normal. So now we can also, well, sometimes it takes a little while to start to see a nice normal shape, but it's starting to look more normal. And if we click right here, what this does is it'll show, well, we know that this is the mean of a certain group of 3 people who have been selected. And if we click there, it'll show us what the 3 people were. So that building block right there, this is a sample mean, and it's the mean of these 3 people. And since these 3 people aren't getting very much sleep, that's why they have such a low sample mean down here. If we click here, that is the mean of a different group of 3 people, but these 3 people are also not getting very much sleep. That's why this group of 3 also has a pretty low average. So this group of 3 people has a mean of 5.6 hours of sleep. Up here, this sample has a mean of 5.7. So well, both of these sample means are pretty close to 5.7. They both round to 5.7, which is why it stacked them above each other. And if we clicked, this is 8 right here. So if we kept moving up this bar above 8, we would just start seeing more and more samples that all had a mean of 8 hours of sleep. So this group of people had a mean of 8.08. Let's go up. That group of 3 people had a mean of 7.9. That group of 3 people had a mean of 7.8. And this group of people up here, they had a mean of exactly 8. So as we keep going up this bar right here, we're just looking at more and more samples of 3 people, and all of those samples had a mean of about 8. Because remember, each of these building blocks in here is just a sample mean. We're just looking at the means of different samples of 3 people that have been selected. If we go up here, we see this sample mean right here is the mean of these 3 people, and these 3 people are getting quite a bit of sleep. Like, that person is getting about 9 hours, that person is getting about 11 hours, and that person about 11 hours. So if the 3 people are getting 8 hours, 11 hours, and 11 hours of sleep, those 3 people will have a high sample mean. That's why their sample mean is way out there. So this is kind of an extreme sample that's getting a lot of sleep. If we click at the low end, we see that this is the mean of another extreme group of people, except this sample is not getting very much sleep, which is why they have such a low sample mean. So here we have an extreme sample who aren't getting very much sleep, which is why they have such a low sample mean. And up here, we have 3 people who are getting quite a bit of sleep, which is why they have such a high sample mean. So here's an extreme sample at the low end. Here's an extreme sample at the high end. But these extreme samples aren't happening as often. What we're starting to see a lot more of are these samples that have that are more medium and not as extreme. And all of these samples in here ended up having sample means in this middle area pretty close to 8 hours. So each building block is a sample mean. Each of these building blocks is a mean of a different group of 3 people. And as we move through here, we're revisiting the 3 people inside each of our samples. So this was the mean of these 3 people. That's the mean of these 3 people. That's the mean of these 3 people. And up here, that was the mean of these 3 people. So so each sample had its own sample mean. And most of the sample means have been at least fairly on target. In other words, most of the sample means have been at least fairly close within to the population mean of 8 hours. Because here we can see that almost all of our sample means have fallen between 7 and about 9. Very few of them have been below 7 or above 9. So most of our sample means have been about within like this distance of the population mean of 8. So most of them have estimated the population mean at least fairly well. And then we've had extreme samples down here and extreme samples up here. Now if we switch our sample size to 30, now what it can do is it can take a sample of 30 people. This is the 30 people in here. It calculates the mean of our sample by adding the 30 numbers and dividing the total by 30. So the dots are the people in our sample. All of these people are sample 1. They're the members of sample 1, and that's their sample mean. If you added the 30 numbers and divided the total by 30, that's their sample mean right there. And if we draw another group of 30, it's a different group of 30 people, and this group of 30 people has a sample mean of about 8.2, and it plots their sample mean right there. So it just calculates the mean of every group of 30 people that we select from the population. We're just selecting more and more groups of 30 and getting the mean of each one. And each time we do it, it shows the 30 selected people inside of the population that they came from. It shows the 30 people on a number line, and it shows their sample mean as a building block. So this right here, this blue block is the mean of our newest sample. So as we calculate more and more sample means, the sample means build up over here. And notice how this time they're more on target than they were before. In other words, the sample means are a lot closer to the population mean than they were last time, because when you take a larger sample, the sample mean usually ends up being closer to the population mean. So we can see that almost all of our sample means so far have fallen between 7.6 and 8.8. So they're all falling pretty close to the population mean of 8 because of our big sample size. But notice how, like I said, the sample means are falling closer to the population mean than they did before, but they're still following this bell shape, this roughly normal curve. So if the population is normal, then the selected samples will end up also following a normal curve, regardless of what sample size you're using. If the population is normal, the selected samples are always normal. And once again, like I said, if you click on a certain block, it'll show you the 30 people that were in that sample. So here's the mean of that group of 30. Here's the mean of that group of 30. Here's the mean of that group of 30. And here's the mean of that group of 30. This was our lowest sample, the lowest sample mean. The reason why this sample mean was so low is because notice how this sample had quite a few people who weren't getting very much sleep down here. So all of these people here kind of brought down the average of the sample. So these people in here caused this sample mean to be so low. This is our highest sample mean. And, well, we have some people here who are getting quite a bit of sleep, who brought up the average. Now we can switch to a skewed population. Click on population 2. So now we have a population of 18,000 people, in which most people are getting lower amounts of sleep, and there's fewer and fewer people getting the higher amounts of sleep. So it's a skewed population. It's positively skewed. Now, what if I select samples of 3? So I draw a sample of 3. It calculates its sample mean. And these are the 3 people. And if you add the 3 numbers and divide by 3, that's the mean of the sample. This is the mean of the 3 selected people. And if most of the population is at the low end down here, then that means that often the sample is going to include people from the low end, like this. And these people are going to bring down, and the sample mean is going to end up having a low average. So let's do it again. Once again, we got 3 people from this low area, and we have that sample mean. And if we keep doing it over and over again, a lot of our samples are capturing all of these sleep-deprived people in the population. And that's why all of these sample means are going to be fairly low. Because if the population is sleep-deprived, you end up selecting a lot of sleep-deprived samples. And all of those samples end up having low averages. So we're getting all of these low sample means now in our graph. And if we keep going, we're going to keep seeing more samples with low sample means and fewer with higher sample means, and the samples are going to form a skewed shape eventually. So let's keep going. It might take a second for it to catch up. And what we can also do is you can say that you want to draw 100 samples at once and click on. If I typed in 100 in here and I clicked on draw samples, it would take 100 at a time. So when the population is skewed, the sample means that you're calculating end up forming a shape that's skewed, just like the population, if you're using a small sample size. So if you're taking small samples from a skewed population, the sample means end up forming a skewed shape like this, just the same shape as the population. But what if I raised my sample size to 30? So I take a sample of 30, I get 30 selected people, and it calculates the mean of those 30 and plots the sample mean. Takes another 30 and calculates the mean of the new sample of 30 people. And it does it over and over. And we're just plotting all of our sample means in here. Since I'm using a bigger sample size, well, notice how since I'm using a bigger sample size, the sample means are more on target. In other words, they're falling closer to the population mean of 8 than they did before when I was using samples of 3. But what's also happening is that the sample means are no longer skewed. They're following a normal shape, even though the population that I'm sampling from is skewed. And let's think about why it's forming the shape. Well, let's look at this sample right there. When you take a big sample, like this sample right here, your sample members tend to be spread out across the entire population, like they are here, with some lower people and some higher people, which is why the sample mean tends to be somewhere in the middle. Because if you have some low people and some higher people in the sample mean is in the middle probably. So back when we were taking small samples, we tended to get 3 people down here at the low end over each time. And when that happened, each sample mean ended up being pretty low, or at least usually low, and the sample means piled up at the lower end more quickly than and it ended up forming a skewed shape, a positively skewed shape. Because when we were selecting 3 people at a time, we often tended to get 3 sleep-deprived people in our sample who ended up having a low sample mean. And all of those sleep-deprived samples ended up piling up toward the low end and piling up down here and making a skewed shape. But what's happening now is that when we're selecting 30 people in our sample, the 30 people inside each sample tends to include at least some people who are getting more sleep up here. So these samples of 30 do still include a lot of sleep-deprived people. There's usually more people up here mixed in who bring up the average, and that causes the sample means to be less skewed. So basically what we're seeing here is that what we saw is that when the population is normal, the sample means always follow a normal shape, regardless of what sample size you're using. If the population is skewed, then the samples follow a skewed shape. The sample means follow a skewed shape if you're using a small sample size, and they form a roughly normal shape if you're using a large sample size. So if population is normal, sample means are always normal. If the population is skewed, the sample means are skewed with a small sample size, using a small sample size, and are roughly normal using a large sample size. And like I said, if you go here and click on each building block, you can revisit the people inside of that sample. So that's the mean of these 30. That's the mean of these 30 people. That's the mean of these 30 people, and that's the mean of these 30 people. Like each building block is just a sample mean. Each building block is just the mean of a different group of 30 people who have been selected. So this is just a big pile of sample means.